Greetings one and all, and today we are going to discuss about derivation of energy of an orbit. So previously we've discussed about derivation of radius of an orbit, which was assumed to come out as n square upon z is equal n square upon z into a naught. Now we're going to discuss about energy of an orbit. So basically the total energy inside an orbit is equals to what? Total energy inside an orbit is equals to potential energy plus kinetic energy. So as we know that inside an electron we are having both energies, potential as well as kinetic energy. Kinetic energy due to motion, potential energy due to position. So here kinetic energy is having its formula, as we have studied in physics, that kinetic energy is having its formula 1 upon 2 mv square. On the other hand side we are having the formula of potential energy. Now potential energy is basically the type of energy which is due to it is a type of energy which is due to the position. Now position of an electron, for suppose we are having an electron here, we are having an orbit, we are having another orbit which is quite smaller than this is another one orbit, and inside that we are having uh, a very tiny oops yeah, inside this we are having a tiny nucleus. This is a nucleus, this is orbit, and this is a second orbit. So here for suppose we are having this is nucleus, this is electron. Now potential energy inside an electron is due to the position of an electron. Now position of an electron inside the electron is maintained position of an electron inside the electron is maintained in such a manner that, for suppose this is the position of an electron and it is revolving inside the orbit, it is maintained inside the orbit. That is why this orbit is also known as energy level, energy shell, energy orbit, or stationary energy level. Why is it called as stationary energy level? As we have studied in Neil Bohr atomic model, it is known as stationary energy level because it is having a constant energy. It is not releasing energy, due to which it is having a constant energy, due to which it is having a constant energy. So it is a stationary energy level due to which it is having a constant energy, stationary energy, or same energy. So here what we are going to discuss here is that potential energy is due to what? Potential energy is due to two phenomena. First, because of the charges of electron and proton. Electron and proton are oppositely charged, both attract each other, due to which they generate a force of attraction. That is why this causes to first make the potential first causes to make the position of an electron within the orbit, which is due to the attraction of electron with proton, due to which it causes to maintain the attraction of electron and proton, due to which it causes to move inside the orbit. And this is only because of the attraction of electron and proton first, due to which it generates a force, which is known as electrostatic force, due to which the electron is allowed to be remained inside its position of the orbit. Secondly, we are having the phenomena of centripetal force and centrifugal force. We know that centripetal force and centrifugal force are both equal inside an uh, orbit. Centripetal and centrifugal force of an electron are equal, due to which the electron moves inside an equal moves into inside a stationary energy level within the nucleus, around the nucleus within the orbit. So basically this is how we calculate. So potential energy is basically, here we are having potential energy. How can we calculate potential energy? Potential energy can be calculated by Coulomb's constant. The value which we previously found was in such a manner that we were having basically uh, we were having Coulomb's constant Z square upon 4 pi Z square upon 4 pi epsilon naught R square. Now apart from this, we were also having the complete value Z square upon 4 pi epsilon naught R square. Let me just write it down so that I may. So here Z square upon 4 pi epsilon naught R square is equals to what? It is equals to mv square upon R, due to which the final formula ultimately became what? Due to which the final formula ultimately became MVRN is equals to NH upon final formula ultimately became 1 e square upon 4 by epsilon naught R. How did it come? Because previously we were having Z square upon 4 by epsilon naught R square is equals to MV square upon R. After simple multiplication, algebraic um, operations, by simplifying it, by solving it algebraically, both of these were simplified, due to which the final answer came to be 1 upon 4 pi epsilon naught E, not 1 upon 4 pi epsilon naught, but Z E square upon 4 pi epsilon naught R. This is the final equation. And how did we obtain it? We obtain it by means of the Coulomb's formula, and by simplifying Coulomb's formula with the angular momentum which we obtained previously. So I won't be repeating the mathematical calculations once again, because it's time consuming, and as you have previously understood, that would be easier for you. From equations 1 and 3, we are going to utilize 1 upon 2 mv square minus mv square, due to which now if we are going to minus that, so this condition will result into, first of all, 1 upon 2 mv square upon 1 upon minus mv square, due to which it will become minus 1 upon 2 mv square. But here there's of course mathematical calculation. We are going to take the LCM. After taking the LCM, we are going to take uh, the one, actually, let me just solve it so that you may get clear about it. Suppose this is the condition, 1 upon 2 mv square upon 1 upon 2 mv square. Now instead of writing 1 upon 2 mv square, we are going to take 1 mv square common. Mv square will be taken common. As mv square will be taken common, the answer will be 1 upon 2 minus 1. Now 1 upon 2 minus 1 is equals to what? It is equals to minus 1 upon 2. So it will become minus mv square upon 2 will be the answer. I hope this sounds clear. After which we have to discuss on solving equations 1 and 2. We have, uh, first of all, previously we were known about uh, the value of velocity. What is the value of velocity? Value of velocity is mv square. Uh, Value of velocity is equals to e square upon 2 pi epsilon naught nh. And how did we calculate that? We calculated it by means of the formula which we previously utilized in the radius of an orbit, in which we calculated the value of velocity as e square upon 2 pi epsilon naught nh. But here, as we require the square of velocity, so we are gonna square it. After give squaring it, the value will be equal to e power 4 upon 4 to e power 4 to the 4 pi 4 epsilon naught whole square n square h square. So afterwards, when we are gonna when we are gonna multiply it, when we are gonna multiply both of these conditions, when we are gonna multiply both of these conditions, there would be the answer, which is minus me power 4 on 8 epsilon naught square n square upon h square. Now here in this condition, we are having constants as well as variables. We are going to separate the constants and variables, due to which it will become minus z upon n square will be separated. Both of these are what? These are what? Variables. And rest of the condition, which includes me power 4 upon 8 epsilon naught whole square h square will is the constant value. It is the constant value, and when we are going to calculate this constant value, we will have our answer as 2.18 into 10's power minus 18. 2.18 into 10's power minus 18. After which, uh, as we know that this value is for atoms, this value is for joules per atom. 2.18 into 10's power minus 18 is the value for joules per atom, which means in order to convert it into kilojoules per mole, we need to multiply it by Avogadro's numbers and divide it by 1000. So as we are going to multiply it with Avogadro's number divided by 1000, it will ultimately become minus z minus z upon n square minus z upon n square 13. I won't be solving it, as we are known about Avogadro's number and how to convert joule per atom into kilojoule per mole. We are going to just multiply with Avogadro's number divided by 1000. So it will become 1313 So that would be kilojoule per mole, of course, and that would be the final equation, which is minus z upon n square 1313.35 into 1313.359 into 1313.359 into, so ultimately the answer will become, I guess, let me just clear it a bit. Oops. So here we have minus z upon n square 1313.359 kilojoule per mole. So this is our final equation which is used to calculate the energy of of the orbit of an electron, and there are some MCQs point as well, that if the orbit is increased, if the number of orbits are increased, energy is decreased. If the protons are increased, energy is increased. And these are some simple MCQs that we can calculate by physics. So here, if number of orbits are increased and the energy is decreased. If protons are increased, so if protons are increased, then energy is increased. And that's quite prevalent, as you can see in the diagram as well. That's the orbit which is having more value, which means the orbit which is far away from the nucleus is having more energy. The orbit which is far away from the nucleus is having more energy because it is away from the nucleus, away from the electrostatic forces of attraction, due to which it is having more energy, more excitability to jump and react with another atom. So hopefully you enjoyed the video, and a few point I would like to discuss here is that whenever an electron moves from upward shell to downward shell, or downward shell to upward shell, or just moves from one energy level to another energy level, then it moves linearly. And if the electron moves inside its own orbit, it moves angularly. And this is all about today's topic. And if you are facing any confusion, you can contact um, me via my email, or you can just comment down in the comment box. So hopefully you enjoyed the video, and we'll meet again.